Hi, everyone. I'm hoping the majority of us will get this lesson in person, or at least have to watch it first and then get an update of it in person. We're going to be dealing with perpendicular lines, once again, not writing the proofs of them, but looking at different characteristics that perpendicular lines have. So, one of those things we're going to look at is finding the distance from a point to a designated line. Perpendicular segments are actually the shortest distance you can get to attach that point to the line. And we want to find the distance or the length of that perpendicular segment that would connect the point to the line. So I have an example here of just any random point A connected to the line K. And the shortest distance would be from A down to B. And notice it makes a perpendicular intersection point. If I was to draw other lines, let's say I drew a line going over here or over here. Oops, that one was a little too long. But they are longer than that perpendicular segment. You're going to need to remember the distance formula. So in this example here, I put it on this next slide, the same thing. We're going to find the distance from point A down to point C because we want to find the distance from point A to line BD. And this is the shortest segment that we want. So we have to remember the distance formula, which was the giant square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to be looking at just A down to B, and maybe it'll help if I highlight it a little bit instead. I'm sorry, A down to C to be connected to BD. So to plug in our formula, I'm going to make A my first point, and I'm going to rewrite the coordinates on the graph, which are -3, 3, and then C is going to be my second coordinate, which is going to be 1, -1. And we're going to go ahead and use our square root, and you are going to leave your answer as a radical. Again, try and simplify it if you can. If not, leave your answer as a radical. I do not want decimals. My x2 would be 1, and my x1 would be -3 or minus -3 squared plus my y2 is -1 minus my y1, which is 3 squared. And we're going to go ahead and keep simplifying. And that's going to be 1 minus -3 is 4 squared plus -1 minus 3 is -4 squared. And once again, keep simplifying. 4 squared is 16. -4 squared is also 16. And we're going to get the square root of 32 as the distance from A to line BD. If we can simplify this, because I know some of us can, I would like to see that we have 4 radical 2. So try and see if you can simplify it. But if you can only get to the square root of 32, that's okay with me. So whenever I ask you to find the distance from a point to a line, you're looking at only the perpendicular segment, no other segments. So in this example here, I would like you all to do this example on your own time. I would want to find the length or the distance from point E down to line FH. So I want to use, once again, this perpendicular segment. They don't always run down the middle of the triangle that's created, but look for the perpendicular segment. And again, maybe it will be helpful if I draw it in another color in red. You would be using point E and point G in your distance formula. We're also going to be looking at something called a perpendicular bisector, and for some reason, all of the words aren't showing up. But a perpendicular bisector evenly cuts a segment in half. And remember, the word bisector means to cut in half. So based off of this diagram, looking even at these two lines going on either side of line N is the perpendicular bisector. So let's put line N is the perpendicular bisector in this example. And because it's bisecting the segment PQ, I'm allowed to conclude that the segment PM is equal to the length of segment MQ. And once again, remember your labeling correctly. Segments are just a bar across the two letters that you use. Different theories and theorems, about perpendicular lines. One of them is called the linear pair perpendicular theorem. And it says that if two lines intersect to form a linear pair of congruent angles, then the lines have to be congruent. So in this example here, I am telling you that angle 1 and angle 2 are a linear pair, and they are also the same measure because of those little arches that are there. So because those arches are the same value, a linear pair can only have the same measure if both of those angles are 90 degrees. So that is why when two lines intersect each other and the linear pairs is congruent, they both are 90 degrees. So they are perpendicular lines to each other. The perpendicular transversal theorem, remember transversal is any line that cuts through two or more lines, says that if a transversal is perpendicular to one of the parallel lines, then it is also perpendicular to the other line. So in this example here, I am telling you that line J is perpendicular to the first line, line H. So that means you can conclude that line J is also perpendicular to line K. So looking at this example here, yet another one, we have lines perpendicular to a transversal theorem. It's very similar to the one I just gave you. And it says that if two lines are perpendicular to the same line, then they would be parallel to each other. So in this example, if M is perpendicular to line P and line N is also perpendicular to line P, then M and N must be parallel to each other. And that should make a little bit of sense to you because if they're going through the same angle of line P, they should never cross into each other because they're both intersecting it at the same angle. And that's all this section has to conclude. I do want to go back to this example. What you could be given is maybe a variable expression that you'd have to find x for. So let's just say I told you that PM was equal to 2x minus 6. Sorry again for my terrible writing here. And then I told you that on this side of the equation, we had that this segment length is x plus 12. If I wanted you to solve for x, you would set both of those expressions equal to each other. And remember back to chapter 1 when we dealt with bisectors, x plus 12. And to solve for x, I'd subtract x this way, so I'd have x minus 6 equals 12, or x is equal to 18. You would also then be able to find the segment lengths. So maybe I wanted to find the length of MQ. The length of MQ would be 18 plus 12, which is 30. You could find the length of PQ. So that would be 60 because you would just double it. But I don't really give too many questions like this on the quiz. I focus more so on the distance formula again. So make sure you remember that. I hope to have this lesson done with all of you in person at some point. But if not, make sure you watch this video, take some notes down. This is from 3.4, the last section in chapter 3, and the last section that will be included on our chapter 3 test. And you can find these notes on the portal.